Hello, this is the answer video for homework 2.2, changing a figure's size and location. Today in class we talked about problem 2.2, which not only enlarged or shrunk figures, but also moved them left and right. So we talked about different rules, and that a rule to make a figure bigger, you would multiply. So you'd take the x and the y and multiply it by 2, say, or to make it smaller, you'd multiply it by a half. And then adding or subtracting just moves figures left and right. We talked about how all shapes, if your x and y are multiplied by the same value, will be similar even if they have a minus or a positive after their x and their y. This homework, though, is just talking about making them bigger or smaller. So the first thing was, on a grid paper, draw a parallelogram ABCD with vertex coordinates. The vertex are just the corner points. So you should have drawn this parallelogram, which has points 0, 2, 6, 2, 8, 6, and 2, 6. And I'll show you mine in just a minute. I just want to go through all the points first. The second was, write a rule to find a coordinates of a parallelogram that is larger than, but similar to ABCD. Test your rule to see if it works by plotting below. So if you want to make a parallelogram that's larger, but still similar, then you just need to multiply your x and your y value by the same value, and it has to be greater than 1. So you could choose any number greater than 1. The rule would be then k times x or k times y. For my example, I just chose 2. So my rule is 2x, 2y, which if I take all of these points and double them, a becomes 0, 4, b becomes 12, 4, c becomes 16, 12, and d becomes 4, 12. And then I also want to find another rule that makes a similar parallelogram but smaller. So again, just to keep things easy, I picked half. So it could have been any number less than 1. So sx, sy, I chose 1/2. So my points now are 0, 1, 3, 1, 4, 3, and 1, 3. If I then take and plot all those, scroll down here, then we get these. So it looks a little confusing with all three on here, but this is the first one, A, B, C, D, my original parallelogram. So that's what everyone should have had, that, A, B, C, D. This is my bigger parallelogram. I'm calling it A prime, B prime, C prime, and D prime here. I picked 2, so my parallelogram is 2 times bigger. If you picked 2, your parallelogram would look just like this. If you picked 3, it'd be 3 times bigger. If you picked 1.5, it'd be 1.5 times bigger. But it'd be something looking in this shape. It would still be a parallelogram, and it would still be similar. Here's my little one. I'm calling A double prime, B double prime, C double prime, and D double prime. And it's half as big. So this is my little shaded one here, so the blue with the overlap. So here's my half as big, here's my 1 times my regular one, and here's my twice as big. So your picture should look something like this. If you use different numbers, it's going to look a little bit different, but otherwise it'll look similar to this picture. The last two were just multiple choice questions, and before we get into that, we'll do our secret word. And since we missed it, I'm going to make the secret word Valentine's Day. It was a Valentine's Day snow day and my birthday, so it was a good day to have off, I guess. So again, the secret word is Valentine's Day. For this one, for exercise 16 through 17, what is the scale factor as a percent that will result if the rule is applied to a point x, y in the coordinate grid? So this is where I talked about that, how you can take the number that you're multiplying the x by and turn it into percent. So if you had 2x times 2y, or 2y, then it'd be 200%. In this case, we have 1x, sorry about that, 1x, 1.5x, 1.5y. So 1.5 times something, you move the decimal 2 places to the right, so that'd be 150%. 7/10x, 7/10y. Again, 7/10 is 70 hundredths, which would be 70%, and that's not actually a choice in this list, so that would be J, none of the above. So there's the answers to homework 2.2. Thank you.